Hello, today we'll discuss some networks and we'll solve the problems on the some networks. So in previous lecture we have discussed the Kirchhoff's laws. The Kirchhoff's laws the which is we can define as a Kirchhoff's current law and Kirchhoff's voltage law. Current law is called as the first law and the voltage law is called as the second law. So in current law we have discussed that at any instant the algebraic sum of the current at a junction in a network is zero. That is a Kirchhoff's current law. And Kirchhoff's voltage law, suppose consider any loop and at any instant in a closed loop, the algebraic sum of the EMF acting around the loop is equal to the algebraic sum of the potential difference around the loop. So now let us consider this network and we have to calculate the currents in the network shown in the figure. So we have to calculate here these currents, this I1 and I2 we have to calculate. I1 and I2. So there are two loops are there. This is first loop and this is the second loop. Okay. So we have to calculate this current I1 and I2 and the voltage source are given like this. Okay. So here it is not mentioned by which law we have to find the current flowing through these networks. Means whenever it is not mentioned, suppose find this find the current flowing through the circuit by using the superposition theorem or Thevenin's theorem or any other theorem. If it is not mentioned here, we can choose whatever the law we want to apply to the given circuit, whichever law you think that it is feasible to apply to this networks we can apply. But whenever it is mentioned that if you have to use the Thevenin's theorem, then definitely we have to use only the Thevenin's theorem to find the current through the circuit or voltage drop across the circuit. So unless and until it is not mentioned, we can go by any laws to find the current flowing through the circuit. Now see here, no law is mentioned. So we have to just calculate the current in the circuit shown in figure. So we can use any law and it is very easy to apply the basic law, that is Kirchhoff's voltage law and Kirchhoff's current law. So apply Kirchhoff's voltage law to first loop, this loop. Now we are going from negative to positive. So there is a rise in potential and again we are going from positive to negative. There is a fall in potential. So it is a minus 1 into I1. Again we are coming here. So there is again fall in potential. So it is a minus 18 into this total current flowing through the circuit. This is a I1 plus I2. So this is a 18 into I1 plus I2 is equal to 0. We have to solve this further. So this is a 10 minus I1 minus 18 I1 minus 18 I2 is equal to 0. So this is becoming 19 I1 minus 18 I2 is equal to minus 10. You can change this sign as all this coefficient having negative sign. If you multiply it by negative, it will become positive. So this is the equation number 1. So after applying the KVL to the first loop, now we have to apply the KVL to this second loop. This is the second loop and we have to apply this KVL to this second. So this is a EMF source is always is already there. So we have to apply the KVL to this loop. So it is a 20 as we are going from negative to positive, rise in potential 20. Again we are coming here. So because of this drop there is a fall in potential. So we have to write here apply KVL to second loop. Okay. So it is a 20 minus 18 into I1 plus I2. Okay. So we can solve this further. So it is a minus 18 I1 minus 18 I2 is equal to minus 20. So we can change here sign of the equation, as all the coefficients are having negative sign, just multiplied by the, so I think this is a, so it is a 20. This is equation number 1. Now we have got equation number 1 and 2. We have to just subtract this equation so that we can omit here I2 and we will get current I1 here. Okay, so that will do here. 19 I1, first equation we have got 19 I1 plus 18 I2 is equal to 10. This is our first equation. Second is this 18 I1 plus 18 I2 is equal to 20. This is second equation. Now we will just subtract this equation. If you subtract this, here it is plus sign, it will be negative, here plus it is negative, here it is plus, it is negative. So minus 18 I2 and plus 18 I2, this will get cancelled. What is remain here? It is I1 is equal to minus 10. Okay. So we have got here I1 is equal to minus 10 ampere. Now we have to find I2. If you put I2 in this equation, first equation will get, sorry, I1 if you put in this equation, will get I2. So it is a minus 190 plus 18 I2 is equal to 10, which equal to 18 I2 is equal to 90 plus 190 is equal to 200. Therefore, I2 is equal to 200 by 18. This is equal to 11.1 ampere. So this is the I1 and I2. And what we have to find? We have to find the current I1 and I2. Yes, it is, we have already found. But I1 and I2, this we have found I1, I2, but we have to find I1 plus I2. This is remain I1 plus I2. So I1 plus I2 is equal to, I1 we have got minus 10 and I2 we have got 11.1 ampere. So this is a 1.1 ampere.